Hi everyone, in this video on inverse functions, we're going to be learning how to find the inverse function of an exponential function, as well as the inverse function of a logarithmic function. And for that, we're going to be working through the two examples that we see on the screen here. Now, if you're up for it, go ahead and press pause and try working through these two examples before watching the rest of the video. But either way, let's get started. For this first example, example 1, we're told given f of x equals to 3 times 2 to the power of x minus 1 plus 5, find inverse f of x. That is, the inverse function. Okay, well as I always do, I'll start by writing SOL here for solution, and I'll quickly copy the function that's given there. That's f of x, which equals to 3 times 2 raised to the power of x minus 1 plus 5. Okay, now to find this function's inverse function, we're going to follow the same two steps that we usually do. Those being, starting from y equals to 3 times 2 raised to the power of x minus 1 plus 5 at the end. Step 1, we swap the x and the y's that we see in this function. In other words, I'll rewrite this as x equals to 3 times 2 raised to the power of y minus 1 plus 5. And as such, that's step 1 done. So we move on to step 2. Now, in step 2, our goal is to rearrange this in order to make y the subject. And for an exponential function like this one, the first thing we'll do in order to do that is isolate this exponential term. That's the 2 to the power of y minus 1 that we have here. And so with that goal in mind, the first thing I'll do is get rid of this 5 that's being added to the right-hand side, which I do by subtracting 5 from both sides of this equation. So that we get x minus 5 equals to 3 times 2 raised to the power of y minus 1. The next thing I'll do is get rid of this 3 that's multiplying our power of 2 here, and to do that I'll divide both sides of this equation by 3. And so we have x minus 5 over 3 on the left-hand side, which equals to 2 raised to the power of y minus 1 on the right-hand side. Okay, now at this stage we've isolated our exponential term, the 2 raised to the power of y minus 1, and remembering that our goal here is to make y the subject in all of this, we need to get this power y minus 1 away from the exponent. And for that, well, since this is a power of 2, we're going to use log base 2. Indeed, the whole idea here is to make use of the fact that the functions log base 2 of x and 2 to the power of x are inverse functions of each other. And so what we could write here is applying log base 2 to both sides, 2 dots. This would become log base 2 of the entire left-hand side, so that's x minus 5 over 3, which will equal to log base 2 of the entire right-hand side, that's 2 raised to the power of y minus 1. But now, since log base 2 of x and 2 to the power of x are inverse functions of each other, this log base 2 of 2 raised to the power of y minus 1 will simply turn into y minus 1. In other words, this becomes log base 2 of x minus 5 over 3, which equals to y minus 1. We're nearly there. To make y the subject now, we get rid of this 1 that's being subtracted from the right-hand side, which we do by adding 1 to both sides of this equation. And so this becomes log base 2 of x minus 5 over 3 plus 1 equals to y. And I'm not very happy with the way that y is written. There we go. So that's equal to y, like so. Okay, now if I carry on right here to state my final answer, we can rewrite this result, writing it from right to left. In other words, we can write it as y equals to log base 2 of x minus 5 over 3, with a plus 1 at the end. And we can now define our inverse function. Inverse f of x is equal to log base 2 of x minus 5 over 3 plus 1. And that's the answer. Remember, an important step in our working here was making use of the fact that log base 2 of x and 2 to the power of x are inverses of each other. Indeed, that's what allowed us to get this power y minus 1 away from that 2. That being said, I carry on and work through example 2. Now in this example, we're told, given f of x equals to 2 times log base 5 of 3x, and minus 1 at the end here, find inverse f of x. Okay, well again, I'll go ahead and write SOL for solution, and once more I'll copy that function, that's f of x, which equals to 2 times log base 5 of 3x, and we have minus 1. Well, as always, I'll rewrite this as y equals to 2 times log base 5 of 3x. And I take away 1 at the end there. And now I follow the regular two-step method. So step 1, I swap the x's and the y's. So this y will become an x, and this x will become a y. So that's x equals to 2 times log base 5 of 3y minus 1. Next, I move on to step 2. And in step 2, remember, our goal is to rearrange all of this in such a way that we make y the subject. And in order to do that, we'll start by isolating this log base 5 of 3y. In other words, we need to get rid of this 2 that's multiplying it, and we need to get rid of this 1 that's being subtracted from the right-hand side. And I'll start with that. I'll start by adding 1 to both sides of this equation to get rid of that 1. So I'm adding 1 to the right-hand side, and I'm adding 1 to the left-hand side as well. So this becomes x plus 1 equals to 2 times log base 5 of 3y. I carry on, and I now want to get rid of this 2 that's multiplying the log that we have here. And since this 2 is multiplying the log, to get rid of it, I'll divide both sides of this equation by 2. So this turns into x plus 1 over 2 on the left-hand side, and that's equal to log base 5 of 3y on the right-hand side. And at this stage, we've isolated the term which contains the y. And so now the question becomes, how do we get this y outside of this logarithm? Well, in a similar way to what we did with our log base 2 and our power of 2 earlier on, here we can make use of the fact that log base 5 of x and 5 to the power of x are inverse functions of each other. And consequently, what we can do here is place the entire left-hand side as an exponent on a power of 5, and we'll do the same for the right-hand side. Here's what I mean. I'll rewrite this as 5 raised to the power of x plus 1 over 2 equals to 5 raised to the power of log base 5 of 3y. But now on the right-hand side here, since 5 to the power of x and log base 5 of x are inverse functions of each other, this power of 5 and this log base 5 cancel each other out. And this entire right-hand side simply turns into 3y. So writing that out here, this becomes 5 raised to the power of x plus 1 over 2 equals to 3y. Finally, all we have to do now is get rid of this 3 that's multiplying the y, which we do by dividing both sides of this equation by 3. So this becomes 5 raised to the power of x plus 1 over 2, and all of that's written over 3, which equals to y. We're nearly there. I'll simply carry on up here, and I'll rewrite that from right to left as y equals to 1/3 times 5 raised to the power of x plus 1 over 2. And I should say I could have left this 5 to the power of x plus 1 over 2 over 3 as we had it down here, but I personally prefer to just have this factor of 1/3 at the front. But the choice is all yours there. Finally, using this result, we can state our final answer as the inverse function inverse f of x is equal to 1/3 times 5 raised to the power of x plus 1 over 2. And that's the final answer. And there we have it. That's how we can find the inverse function for an exponential function as well as a logarithmic function. There we go, everyone. I really hope that helped, and if it did, please hit like on this video, drop a comment down below, and even subscribe to this channel to help get this video to as many students as possible. All that being said and done, that's it for this tutorial.